Good afternoon, all. Myself is Vigneshwari from the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So today I am going to take topic on a flip-flop from the subject Digital Principles and Computer Organization from the unit Sequential Circuits. So before moving into the topic of flip-flop, let's recall about what is a combinational circuit we discussed in the previous video. So combinational circuit is a specific task we will be using the combinational circuit without any memory element being used there. So it could be a simple arithmetic and logical operations like adders, multiplexers, comparators, encoders, decoders, and then code converters. But here, since we lack memory element, we switch to sequential circuit. So in sequential circuit, we have two categories. One is synchronous circuit, which is in sync with the clock pulse assigned, and asynchronous circuit, where we are not going to rely on the clock pulse. Instead, we'll be having a preset and enable, right? Here, flip-flop, it deals with the synchronous circuit. So today's topic for discussion is why do we need memory element in digital systems? What is a flip-flop and types of flip-flop and its application? So let's explore about what is a flip-flop. So you can think of flip-flop as like a switch, like an on-off switch, right? So when the clock pulse is being applied to the flip-flop, it switches its state either from off stage to on or from on state to off. This is how a simple flip-flop is. So why do we need memory elements in digital system? So what is the necessity to have a memory element? So basically digital system, it relies on the binary form ones and zeros, right? So in order to remember what was the last state, right? It could be on or off state as such. To remember the past state, we need a memory element in the circuit. So here the combinational circuit what we discussed in the previous session, it doesn't have any memory element to store such data of the past state. And hence we need a memory element to be inbuilt in the digital system to know about what was the state that was previously being used. Like this we are comparing with the analogy of a light switch. It could be on or off and retaining the switch to be in the pressed state even after a finger is being removed from the switch. So flip-flop is basically a building block of such memory element in the design of such sequential circuits. So now, what is a flip-flop? A flip-flop is a bistable multi-vibrator. A bistable multi-vibrator where it could store a single bit of information. So single bit of information, which means it could be a state 0 or it could be a state 1. So the output here depends upon the input and also the previous state. So it depends upon the present state input and also the previous state what we have been applied in the earlier, and this has been classified into SR flip-flop, JK flip-flop, T and D flip-flop. So basically 0 represents the logic low state and logic 1 represents the high state. So as we've seen, so which flip-flop type will be used for a specific application? Say for example, the SR flip-flop, SR which stands for set reset flip-flop. This is suitable for a straightforward applications, right? So where we are going to implement only on the present state and the input directly as such, SR flip-flop will be used. And JK flip-flop, JK is Jack Kilby flip-flop. So since this JK flip-flop is advanced from the SR flip-flop where it toggles the state when both the conditions are being set to a high state, which is logic 1 state. And coming back to the T flip-flop. T flip-flop is a toggle flip-flop where the output state will get toggle when this is being applied as a high along with the clock pulse. And then the last is the delay flip-flop or the D flip-flop where it could store the data and it is useful for the creating a delay in the circuit, and this is straightforward used in the applications of a registers. Whatever registers it is, we could be using the D flip-flop. Coming to the SR flip-flop, as we seen, SR is a set a reset it is a basic latch. So SR flip-flop with S as a set condition and R as a reset condition, it works on all the states. Say for example, when both the inputs are being 0, it remains in the no change of the state and it remains as such in the present state. When the S is equal to 0 and R is equal to 1, it resets the flip-flop. I mean, set is equal to 1 and reset equal to 0, it resets the flip-flop. And 1, 1, when both the set and reset are being given a logic high state, this is being used as an indeterminate state. So this could be used as a basic memory element. Next, coming to JK, D and T flip-flop. So as we said, JK flip-flop, it toggles the state as we seen in the SR flip-flop. Both are being applied as a 1. Here in JK flip-flop, when both J and K are set to 1, it toggles the output state. And coming to the toggle flip-flop, when J and K both are being used as 1, right, this is being used in the counters where it toggles the present conditions. And delay flip-flop, it is being used in the registers, and hence what we given the input that will be stored as in the registers in the memory. Next, we are coming to the design of a JK flip-flop. Since JK flip-flop eliminate the indeterminate state of the SR flip-flop where S and R is equal to 1, here J and K is equal to 1, it toggles the condition. So flip-flop are being used in counters, shift registers and memory circuits. So for basically counters we use T flip-flop and for shift registers we'll be using D flip-flop. Whereas in the case of a memory element, both JK flip-flop and D flip-flop are being implemented. So let's quickly summarize about the flip-flop. So as we seen, the flip-flop types have been SR flip-flop, JK flip-flop, delay flip-flop, toggle flip-flop, and apart from that we have a master-slave flip-flop also. So coming back to a curiosity challenge. So here the condition is when the flip-flop given an input sequence, what could be the output sequence? Since a delay flip-flop, it depends upon the conditions of the input as such. Here, it output the displays will be the same 1010. So which flip-flop is called the universal flip-flop? Yes, JK is called the universal flip-flop and the output of the T flip-flop toggles when T is equal to 1. So thank you, and I have referred Maurice Mano and Geeks for Geeks tutorial websites. Thank you.